Thank you for inviting me here today to speak. My name is Kris, and today we're going to be going over the OWASP Top 10 for developers. So, who am I? Well, I'm the lead penetration tester for Stenton Associates. Previously, I worked for True Digital Security, so you guys might have had interactions with them before. I've done IT for well over a decade. Did web dev as a freelancer for 2 years. Started the Oakland City Ethical Hackers. I've got a couple certs under my name and some fancy letters, so nothing too special. So today, I see a lot of laptops. Don't worry. Let's not take notes just yet. We can do that at the end. I promise there'll be a spot at the end where we can come back and take notes. I want eyeballs on what we're doing. I want you guys engaging what all we're going over here. What about tools? Are we going to talk about tools today? This is not a tools talk. I don't want you to think, hey, we should be talking about, okay, what's the latest and greatest tool? How can I incorporate Selenium? Or how can I go get Zap and make all my greatest dreams come true? That's not what we're trying to do here. We'll come back on that. We can talk about some tools at the end, but today is not a tools talk. So, well, what is today? What can we expect? So, ultimately, we're going to talk about methodologies. We're going to talk about the awareness that the OWASP Top 10 is trying to bring and really do a deep dive once we go into that. And we're going to talk about prevention remediation. So remediation is the actual act of fixing these items. It'll be a little bit more in depth, so we'll kind of reserve that for more Q&A, but there's plenty more slides here if we really want to get into it. Okay, anything we go over today, it's for educational purposes only. Yes, you can use them for your work, but you need to be authorized to do what we're going to talk about today. Please don't go nuts and do terrible things with the information I'm teaching you today. Cool. So, number one on OWASP Top 10 is injection. So, what is injection? Well, this is easily one of my favorites. So, there's all kinds of different types of injection. There is SQL injection. And SQL injection is essentially when you're talking to a web application and you can talk to the back end. And it doesn't have to be SQL, it can be NoSQL, where you're actually able to communicate with the back end and you're able to send some sort of a command, some sort of a SQL clause that will force an action. And there's different types of SQL injection. There's error-based, where if you have a web application and I throw a single tick in there and it responds with an error, then I know I'm able to inject and generate errors from your web application. But there's also blind-based SQL injection, where I can throw that single tick in there, or I can throw in double quotes, or I can plus symbols, or the from clause, where clause, all kinds of pieces, and I'm trying to trigger an error, but I never get to see the error because you're being wise and you're responding with HTTP 200s. You're trying to mask, like something went wrong, but we're not going to tell you what it was. But I can still try and trigger things. So there's still ways of figuring out, well, how did I do that injection? So, well, what if I can tell your server? What if I'm still talking to the SQL server? That's where we're getting execution. What if I can say, hey, I want you to slow down. I want you to wait 5 seconds or wait 10 seconds. If you get this command, wait for 10 seconds. I don't have to ever see the actual act of injecting. I don't have to see the results. I know that I was successful in injecting because your server stopped responding for 10 seconds. And if I'm able to control that, then I know for sure. Well, let's say the server ignores sleep requests, ignores things that tell it to stop responding. Well, what else? What if I'm able to turn portions of the website on and off? I may not be able to see it on that page, but I know I can turn user accounts on and off. This is where I can add columns. I can disable columns. I can do really anything that I can, or just hand it basic Boolean logic, where I'd say, go ahead and give me this information if 1 equals 1. Or if 1 does not equal 2. So there's Boolean logic that it will only display the information that you want, or that they will only change something on the page if you want, if that condition's true or false. And then finally there's union-based, which is the weirdest one of all. So this is where you take one table with another table that don't belong together. They almost never go together, and you merge them. And so let's say you have a page that returns 3 columns. Name, user ID, and email address. And I pull email address out and I want to substitute in their password or from the passwords database or the users table, I'm able to join those tables together. I'm able to union them together. And the cool thing about SQL injection that's union-based is that when you're doing this, you can union really any other table in the database. It's not a big deal. But when you're doing this, the number of columns has to be the same. So if your web application returns 3 columns, I can substitute any of those columns out, but I still have to come back to 3 columns. And there's some really cool injection methods for doing that. So let's say I say, oh, I'm trying to figure out how many columns there are because I may not, with SQL, there's views, so you may not be able to see every single column. It may not actually show as a field on the page. So you can say, well, I want to order by the index of 1, which would assume that there's 1 column. Well, let's say I keep incrementing that up, and I say index by column 3, and it's good. I index by column 4, and it stops, it fails, it breaks. Oh, hey, cool. I know that that SQL view, that SQL query, returns 3 columns because it failed on number 4. So, there we go. And here's a good example of a SQL injection that's error-based. So I'm able to cause an error. And so you're like, well, what's the big deal with an error? What can I do once I have an error? And as a pen tester, I love errors. I can gain so much information. Stack traces are even better. But just an error that says, well, you broke something. Well, okay, so if you look at the top, at the artist equals 1, there's a little single quote up there. I was able to trigger that error by introducing that single quote. And by doing that, I'm able to change the behavior of the application. So now let's say I want to know the contents of your database. I want to know what's the database named. So I can keep sending requests that are going to trigger an errors and effectively do this Boolean based. There are tools, I said we're not going to talk about tools, but there are tools out there that have the ability to generate errors and ask questions like, is the first letter of the name of the database, does it start with an A? Does it start with a B? Does it start with an M for Microsoft SQL or MySQL? You just keep asking these questions. And when you get an error, you know, oh, well, that wasn't it. I can go to the next one. If you get a valid response, you're like, oh, okay, so that is the actual valid response. So what does SQL injection really look like? Well, here's our most classic case of a login bypass. So where we come in here and I say, well, I don't really know the usernames or any of the passwords. Is there a way to bypass that? And the whole idea here, and so this is an example, and if you look at the top, I mean, we're doing a select from where the username equals, and typically we type in admin or Bobby or whatever, but here we're saying single quote or 1 equals 1, and we're passing that in. So what this is saying is it's going to evaluate this, and it's actually going to just ignore that and because it's going to go ahead and look at that or and say, oh, okay, well this is good. We're going to go ahead and allow that through. And this is what we call string building. This is something you definitely want to avoid when you're creating your SQL queries. You want to avoid giving me the ability to build on your string. We've probably heard of prepared statements or query parameterization. This is what you want to be doing. You want to prevent me from doing string building. In fact, I have an entire talk dedicated to nothing but SQL injection. I have the slides. We'll if we have spare time, we can dash through those real quick. But essentially, avoid string building. You don't want to let me do this where we can actually follow through how that information would be evaluated. So where I can do a login bypass. Now, I say all this, there's SQL injection, and SQL injection is one of the really big ones right now. But there's all these pieces that can be done, but SQL injection, if you look at right at the end, this could potentially return tons of results. It will return any results that are found in the table, and this is a common problem for crashing web applications. If your web application is expecting 1 result, and I return 10, or I return 100 or 1,000, probably crash the application. I mean, who knows how it's going to be handled. So it's important if you're going to do this, if you're going to do these tests, that you're going ahead and you're introducing those single quotes, those double quotes, that you're encoding them, doing URL encoding if it's necessary, or base64 encoding, that you're actually providing these, and of course check and see if the application crashes. But there's more injection than just SQL injection. There's also command injection. So, for example, what if I had a URL that looked like this? And what it does, so this is an example in PHP. So, here it says go get username, and that is a %27, which is the, I'm drawing a blank on this one. I believe that one is the single quote there. But then we hit it with a semicolon, and then we say, well, go do something else. So if you have an application that evaluates command-line pieces, we can actually take advantage of that. I can end that, and Unix, Linux, you can start a new query, you can start a new command using the semicolon. And I can say, well, I want you to go cat etc password. I want you to get that information. %27 is a single quote. So what it would do, so if we had that code right there in PHP, it would respond back with, well, hey, I went and actually queried that information, and here's your etc password. That's bad. That's really bad. So there's another one, SSTI, server-side template injection. This one's a big deal. This one is a lot of times not thought about. Nobody really considers what is their server-side templating language doing. So, for example, we could use Twig for an example, where you're actually able to do this binding right here. So we can say, well, I want you to evaluate, because it's expecting binding, but it will do evaluation. Where we say squiggly or curly bracket, 2 times 2, end curly bracket, curly bracket. And what it will do is it will say, hey, typically I would say, hello, Chris, hello, Bobby. But here it's going to go ahead and evaluate as 4. Well, there's full-blown walkthroughs that security researchers spend the time going through and examining, okay, well, if I walk through these and I'm able to trigger certain errors or have it evaluate in certain ways, maybe I can figure out what the server-side templating language is. And this, if we're able to figure it out and we're able to get this information, because once again, your application's returning errors, if I'm able to see when I can cause that error, I can figure out if you're using Twig or if you're using Mako. I can make sense of that in the background. And so it's important that when you guys use any server-side templating pieces, make sure that you are blocking, you're gracefully handling your errors as much as possible. Don't give me any more information than I need to know. If you give me any extra information, I will do terrible things with it. And so here we have the XWiki, which has a really well-known one that allows command injection all through that, all through the UI right there on ID. Okay, so that was a big one. That's number 1 on the OWASP top 10. So what else is there? Well, there's broken authentication, and the real question is, are you giving resources? Are you letting people through the door that shouldn't be there? And so the big problem with HTTP is HTTP stateless. So you have to somehow have the client re-authenticate, well, reauthorize, I should say, every single time. So you have to give them a token. You have to give them something that says, we know who you are. And as long as you give me this token and you have a valid session, that's good. So, but where is that session token kept? Where are we actually keeping that? And the big issue that you'll see a lot of times is people put in the cookie. Well, can I still abuse that? If it's in the cookie, can I actually take advantage of that? Because the browser, by default, when it makes a request to google.com, if there are any cookies for google.com, it will automatically send those. So can I take advantage of that? Can I do a cross-site request forgery? I sure can. If you're on bankofamerica.com and you're logged in and I send you an email, you click it and it says, transfer me $1,000. There's instructions in that link that says, transfer me $1,000. How would you stop that? Because your browser would immediately connect to bankofamerica.com. It would hand over the cookie automatically. That's to be expected. And then it would actually process whatever that GET or POST request would be to actually do giving me $1,000. Cool, thanks. So how do we stop that? So if you want to protect the session cookie, then another way of doing that is to actually insert an additional request verification token, or cross-site request forgery, CSRF for short, token, in the actual application. So on the form, the actual form, the one that you're interacting with, you should have, you know how you have name, or let's say account, date, and amount. So we're setting up a transfer. Well, in reality, there should be a fourth form, or a fourth piece that's actually being passed back to the server, and that is because the server has created a request verification token. It's a one-time token. It will, if you refresh the page, it immediately changes, and then that gets sent back. And essentially, the whole idea is to prevent me, as the attacker, I can't see your session. I'm just hoping to take advantage of automatic behavior that Google Chrome or Firefox are doing. So if I can't see that token, and I can't process that token, then I can't automate that request. I can't abuse that automatic functionality. Well, what if the request, the tokens in the URL? Don't do that. Just don't do that. I mean, there are some occasions where it makes sense to put your session token in the URL if you really want to have it in there. But if you have any sensitive information, if you're putting in the URL, any host, any network device between you and the system you're talking to can be able to pick up that information. Yeah, you can be using HTTPS, but you can still have all kinds of pieces that can pick that information up. Just don't put your session tokens in the URL unless it's absolutely necessary and the information is not sensitive. So how do we also protect the session cookie? Isn't there a bunch of other ways of stealing the cookie? And yes, there is. So if you have your session information in your cookie, well, what if I get a cross-site scripting and I'm able to dump your cookies? Well, how do you protect against that? Well, there's flags on your cookie that can say, well, only communicate via HTTP, block JavaScript. Do not ever allow JavaScript to run. And so turning that flag on disables my ability, even if I get a cross-site scripting on your web application, I can't steal your cookie. But there's other flags. There's browsers. Every once in a while, we'll talk to a web application that's, for some reason, HTTP is still turned on. And when they talk to it, they're like, oh, okay, well, we'll talk in HTTP. That's cool. You know, we don't need to be secure. And when it does that, it still hands over the cookies automatically. Well, anybody that's listening in can snatch those cookies. So you want to make sure that the secure flag is also turned on. The secure flag is where the cookie will always be transmitted via HTTPS. It will always require that. Okay, what about entropy? So this is not a talk about entropy. We could be here all day on this, and I am not an expert on entropy. But if I can easily guess your cookie, if I can easily, well, let's throw this one in there. Session fixation. What if I hit your web application and you immediately give me a cookie? Okay, great. I log in, and my cookie is still valid, the same one you gave me before I logged in. Okay, great. Now I can hit your web application over and over and over again. I hit it thousands of times, and eventually, if it's poorly designed, I will exhaust all of your sessions. I will know every single one of them, and I'll start being able to cycle through them. So that's really bad. You don't want me to be able to cycle through those. And so what you want is a large enough reservoir of difficult to guess cookies or session tokens where I can't sit there and steal or guess them or figure out, okay, if my session token says this, well, maybe if I decrement it or increment it by 1, I can change my user. You really don't want to have that kind of ability. And of course, with authentication, now we have multi-factor authentication. Well, again, same problems that can come with multi-factor if the multi-factor is easy to guess or easy to intercept or just easy to brute force. I had a client that rolled their own multi-factor authentication. I don't know why. Instead of just using a standard, industry standard library, they tried to roll their own. And it was, you needed to come up with a 4-digit code, and they gave you 30 minutes to throw it in, and they didn't terminate your session regardless of how many requests you sent. So, 4 characters, that's 10,000 possible combinations. I can do that in about 5 minutes, easily. I can just increment them. Even if, and oh, they hashed it. It was MD5. Oh no, I say send MD5 of 1 and 2 or 3. That's all I had to do. I could easily work my way backwards, and it was very easy to overcome that. So let's move forward a little bit. All right. Number 3 on the OWASP top 10 is sensitive data exposure. Is your app leaking data? That's a very important question. Are you leaking things? And this may not be just the app. It could also be the servers leaking information away. So the easiest way to think about this is, well, what if you're using HTTP? Well, that's a sensitive data leak. We don't need to jump into that much. Essentially, you should usually allow HTTP turned on, but immediately at the server level, not on the web page. Don't have the page do the redirect. Have the server do the redirect back to HTTPS. Say, I'll accept you coming in, but you need to go over here. This is a secure line. So that's an easy way of seeing sensitive data exposure. Well, what other methods of sensitive data exposure are there? Well, if you can't read that, what that says is the password is being used by another user. Please choose another password. No, this one's kind of egregious. It's very rare you'll see this, but you will see stuff like this every once in a while. So when you're creating a user account, when you're doing a forgot password, I can sit there and enumerate people's information. If I can't create an account with that username or that email address, I know somebody else has it. And the problem is you guys really aren't going to be able to overcome that issue. But if I can do it with the passwords, or if I can do it in quick succession where the server doesn't limit me, where the application says, no, you've asked way too many times, then I can just sit there and brute force and figure out everybody's username and hopefully not their password. And what kind of goes along with this is credential stuffing. There's so many breaches nowadays that there's been so many sensitive data exposures and breaches, compromises that I can just go out to the dark web, find a compilation of these username and passwords, and find ones that will likely work, whether I know that there's very specific users, so I found Space Moses, and I found Space Moses also in one of these breach compilations, and I can try his passwords. I can use his combination of information, and you'd be surprised how often this works. Or if I'm at instead of Gmail, let's say I was at, Bank of America, and I can pose as one of the employees. I can come in as employee login because there's sensitive information that's been leaked out to the public. Basically, you want to give me as little information as possible. Remember, graceful errors is the best way to go. Just say, something went wrong. Don't tell me what went wrong. I don't need to know what went wrong. It doesn't matter. Just HTTP 200, something went wrong. Please try again. Don't give me any more information. Lie to me as much as possible. All right. XML external entity. I don't like this one. I don't like this one at all. So before we go any further, the OWASP Top 10 is a tool meant for awareness. And being that it's meant for awareness, it's more meant to let you know what's going on and to promote awareness, to get people to be critical of this. And so this XXE showed up back in 2017, and it does not belong. Well, let's talk about what is XML external entity. So it looks like this. So if I were to hit any kind of page that has an XML parser, and we've been doing XML since early 2000s that we've had built-in parsers. And for the record, nobody likes writing XML parsers. Nobody likes writing that. If you do, you're weird, but you're a good person. So people generally go grab libraries to do this. And there was a rash of vulnerable libraries right at the beginning that they were vulnerable because you could add this entity tag that said, hey, I need you to go get this external resource. Now, why do I have a bone to pick with this? This problem was solved over 10 years ago. So why is it on the OWASP Top 10? Well, people keep using these libraries as one problem, but also the way the OWASP Top 10 was generated. So this information came from companies like Checksmarks and Veracode, and they helped build out this information. And they did it by analyzing their scan results and seeing what they saw the most of. And XXE came in at slot number 4. But really, where the companies are doing their scans, for the most part, they're not doing it on internet-facing machines. They're doing it on internal machines. Internal machines that are inside the perimeter, that are generally considered inaccessible by most individuals. Internal machines that often don't get patched anywhere near as well, that haven't been updated, that, well, you know, it aids in the ticketing system, but nobody can really hit it. So you have all these applications that exist internally that are getting scanned over and over and over again, bumping this guy up the list. I don't think he belongs in here. Google had a bug bounty that would pay you $10,000 if you found one of these on their site, and they opened that up several years ago, and as far as I know, very few people claimed it. This is a problem that got fixed a while ago. But XXE is on the list. It's something to be aware of. Anytime that you have a web application that processes a Word document or a PowerPoint document, technically it's XML. You know, that there's XML being processed underneath. And the way it works is you send it to you upload the document gets parsed, and it says, oh, hey, server, go get this information. And in a way, this is close to server-side request forgery, where you're actually telling the server, hey, go get that item. Wherever it is, go grab that item and bring it back. And it may or may not display, depending on how the server's set up. You never know, but you may be able to get errors that indicate either A, you got there, or B, you didn't. All kinds of information. But again, I take great issue with this one even being on the list. But I don't get to change the list. Okay, number 5, broken access control. So I once had a client ask me, why do I need passwords to my computer? And I was like, why do I need a lock to my house? I mean, people are evil. Not necessarily evil, but they will be if left unchecked. So IDOR, insecure direct object reference. So what does this look like? So IDOR is, well, really it comes back to authorization. So we talked about authentication, which is when I show up and I show you my driver's license and say, I'm Kris. And you look at it, you may even call up the DMV, is this legit? And you can confirm, I'm Kris. Well, authorization is after the fact. Now, anybody, it's like when you go to the fair. Once you get in, they give you the little armband. You're authorized to be there. Cool, as long as you have the armband. If you have the second armband, you can drink. So what if I can steal people's armbands? I mean, that's an access control issue. I'm able to steal armbands. What if I can just bring my own and start handing them out? What if my armband says, I only paid the $5, but I didn't pay the $15 to get the really good beer? So I can only get the cheap beer. But what if I take a Sharpie and mark it in? Or the beer vendor doesn't even check my armband. And he's like, okay, well, that's cool. You have an armband, so come on in, and here's the premium beers. That's how the insecure direct object references work. That you're already inside. You're already allowed in, but there's no additional checking that should occur. There's no, hey, do you really belong here? So it's interesting to have that discussion. And authorization has so many other pieces other than just insecure, let's go back for a second, then insecure direct object references. So for example, like if I'm on, I log into a page and my user ID equals 12, and I'm like, that's interesting. My user ID up in the URL equals 12. Well, let's set it to 1, which is usually the admin account. If I'm able to get to that, that's also another example of where I'm able to get to information I didn't belong to. A tool that I use quite often, actually I'm not going to name any names. Anyways, directory scanners are a way for me to find out what's there and can I access it with or without credentials. In fact, a lot of times when I'm doing this is I will come in and I will hit your web application. I'll hit it 3 different times every time I make a request. 1 with the credentials you gave me, 2 with credentials I made up myself, and then 3 with no credentials at all. And every time I hit something, and I'll compare those results because tools like Burp Suite, Zap allow you to compare the content length. So as I'm moving around, if I'm able to ask for the /admin page and I can get it with the real cookie, I can get it with the fake cookie that I made up, but I can't get it without the cookie, with the cookie just missing, then I know that I can just have the cookie, put whatever I want in there, and you're going to let me in. Which is, once again, broken access control. It's like the keypad on the side of a door lets you type in 1111 when you know that's going to work for anybody, and it's not doing a very good job of checking for everybody. Or if you're centered and use 0000. All right, so security misconfigurations. So you're probably going to use a framework. The framework's going to be claiming to be secure, but is your server secure? You know, are you doing things to make sure the server is actually nice and secure? So back to server-side request forgery. So what does server-side request forgery look like? So essentially, it is, remember XXE earlier? I tell the server, here's a document. The document has an entity tag. The server's like, oh, I should go get that item. So if I can, remember the directory scanner, if I can scan your web server and I can get, 10 pages, and one of them you didn't really intend for me to ever get to. So I'm able to get to that one. And at that page, he has another option that lets me tell him to go get more pages. A really great way of looking at this is local file inclusion. Local file inclusion and server-side request forgery are similar. So here is a local file inclusion. And so there's a very big difference between server-side request forgery and local file inclusion, because local and file inclusion assumes that you're taking the information, and I use PHP because it's easy to understand for everybody. It assumes that you're including another file with programming language in it. So PHP being one of the biggest offenders of this. So it assumes that you're going to bring it in. So once you can have your document, and as your document comes in, you can say, I'm going to include the languages dot whatever language they gave me. And this is a user-controlled variable, that language piece, because it's a get parameter. I'm able to control the get parameter. I can change language to whatever I want it to be. I can type in all kinds of information. I can come in here. Let's say it's, instead of said page, or instead of language, it said page, and it said, well, get the error page. So page equals error.php. Cool. Well, what if I change it to going up a directory, up a directory, up a directory? In Linux and Unix, you can just keep going and going, because it just ignores it once you hit root. And then I say, well, then get me Etsy, then get me password. Okay, cool. So local and file inclusion assumes that you're going to take whatever text file, whatever programming language file that you found there, and include it into the actual PHP or C# file that you're working with, or ASPX, that you're actually including it directly in, and then it gets evaluated. That's the key difference between server-side request forgery and local file inclusion, is that in inclusion, there is that actual evaluation where they're actually trying to process it. So this was an example of local file inclusion. I said, go get something that's already there on the server. So Etsy password. Well, what if it's not on the server? What about remote file inclusion? And, okay, so what if it just lets me type in a remote link? You'd be surprised, servers do this. Once again, this is a security misconfiguration. This is, you didn't specify which pages I was allowed to include. You didn't limit me, and you should never do it with blacklists. You should always do it with whitelists. You should always say, it's kind of like when you configure a firewall. The first rule is implicit deny. Everything gets denied, and now allow only the items that you actually want to work. The same thought process should work here, that if you want to only allow the error page, you should deny everything. And this is done at the web app level. Deny everything, only allow error.php. Or you could even do the absolute value of error.php. And if you only have one page that gets included, I don't know why you're using file inclusion. But you'd be surprised what people are doing. So again, this is a misconfiguration where you allowed behavior that should never have occurred. And frameworks, Laravel is vulnerable to this if you don't turn off file inclusion, if you don't turn off the server's ability to go fetch resources for you. And that is at a server level and partially a web application level. It's interesting to say where these spots are going to hit you. Okay, so one of the good ones Now you're probably wondering, well, where was this guy on the list? So cross-site scripting, yeah, I love running scripts on your website, on your web application. So it's very important that everybody understands that cross-site scripting is a client-based attack. You are not attacking the server, you're attacking the clients at this point. I'm trying to store cross-site scripting or JavaScript that is meant to attack the user, not the database. Unless we get into prototype pollution, which is something we're not even going to talk about today. It's wild and wacky, cool, and that's why you should be very careful about using Node. Anyways, moving on. So essentially the whole idea is I'm going to either store something on the page that's going to attack the users, or I'm going to create malicious links that's going to attack the users. So there's reflected. Well, what does reflected look like? There we go. So reflected is where the payload is in the URL. So the payload has to be in the URL where I can actually store the script inside of there. Now, this is a very easy to read script. So very easy to read it. Oftentimes, the scripts don't make any sense. Is anybody opposed to me using a curse word at the moment? Any raise of hands. Okay, I did not put this in the slides because there was a chance, somebody would be, okay, I'm going to say the word, but nobody hold it against me. When you guys have some time, go to jsfuck.com. It is mind-boggling the things you can do without writing a single letter or number. That JavaScript does some really bizarre things because the JavaScript's loosely typed, so you can force it to do behavior you would never expect it. And jsfuck.com is a perfect example of how this works. And they just have a bunch of series of parentheses and brackets, and they're able to do full-on cross-site scripting with nothing but parentheses and brackets. Like, you could write in your application, hey, anytime the script tag appears, block it. Once again, we talked about blacklists. Blacklists are bad because I can overcome that by doing some simple encoding. Or I can do character code encoding. I can say, well, go get me character code 65. Go get me character code 70. So unless you have character codes also blocked, well, okay, what about concatenation? Well, I mean, there's so many different ways that I can pass this information through. You really need to come back with a whitelist approach. Only very specific things should be coming through. And regex filters are a nightmare when it comes to this. There is no magical bullet here. It is something you will constantly be updating, constantly be fixing. There's no magical way to make this beautiful. All right, so another type of cross-site scripting is stored. So now the payload is no longer inside the URL. The payload is now directly on the website. Let's say I go and I leave a comment, and your comment section did not do any validation of information. Now I'm able to come in there and drop my cross-site scripting in there. And once again, I may use encoding, so it's not readily obvious. It passes, it's able to escape all your filters. And OWASP has tons of sheets on cross-site scripting filter evasions. So, I mean, there's tons of publicly available information for getting past this. Writing a simple one that says block script's not going to work. Or adding the ones that block the tags is not going to work at all. But this is where I actually go and I deposit it directly on like a comment section. And anytime anybody loads that page and that comment pops up, it's sent to the client and processed on the client. So now it's stored. Oftentimes we call this a watering hole attack. I'm going to go put it somewhere where a lot of people are going to go. And if you didn't protect your cookies, the first thing I'm going to do is I'm going to have it call out to my server and say, hey, call out to the server and q equals, or at the end there's a query string, q equals document.cookie. Cool. So every time that you talk to my server, every time you hit that page and that watering hole, the comment actually loads, you're going to send a request back to my server, the client is, and is going to give me the cookies. Any cookies that are set to not to HTTP only, which is the only way to block that. Cross-site scripting will be a pain, and he's not going away anytime soon. So good luck on that one. There's one more type of cross-site scripting, which is called DOM, so Document Object Model. So this is an interesting one, and I get people who find interesting ways to break their DOM. They'll open up the dev console, and they'll type in crazy things, and they're like, look, I broke it. I'm like, yay? I mean, what's the impact here? How did you attack your victim? How did you victimize anyone with that? What's the real impact of just being able to open your console and changing the DOM? That's not really where it's bad. This is a good example of how you can come in here and make those changes. But where you can change the inner HTML or the search variable right there. So where is the DOM actually important? Well, let's say you have Angular, or you have jQuery. I'm sorry, not jQuery, React. And you guys have these things. Well, nowadays, DOMs are constantly doing things in the background. They're constantly communicating with their services. Angular uses data binding. So if Angular is data binding with the server, and I'm able to intercept one of those communications, and I'm able to throw something else in there, or force the behavior through that data binding to do something was unexpected, that's how I attack your DOM. Your DOM is actively running. Now, a simple page with simple HTML, the DOM's pretty much, he just sits there, he doesn't do anything. But if you have any kind of AJAX requests, any kind of active JavaScript, you can come in here and attack it. It's difficult, I'm not gonna lie, but I can't tell you how many times I see React devs turning off the set, or was it inner HTML set dangerous tag, if they turn that flag off. And yeah, that's where cross-site scripting comes into play at the DOM level. All right, so another new addition to the OWASP top 10 is insecure deserialization. So serial looks, well, let's go back. A lot of people are using JSON nowadays. You can have all kinds of different types of serial, but JSON's our big one right now. So it's gonna look like this, where we're actually passing information in. And this could be inside the cookie. It could be inside of a post request where the body is actually being passed up. You're going to see this, like it blew my mind that I could get SQL injection through a cookie a while back. So just keep in mind, just because you think the cookie can't be attacked, and at worst case it's just going to be stolen, that's not the case. That we can come in and I can decode the cookies if you're using JSON, web tokens, or web encryption. I can come in here and I can parse it out, I can make sense of it, I can turn your encryption off, I can do all kinds of things. And so the easiest way to understand this is that if I'm able to change Mallory, who's marked as a user, and I come in there and say, well, let's make some changes to it. And since serials are so long and there's dangerous elements hidden in plain sight, you never know when one of them is going to bite you. It always reminds me, every time I see one, it reminds me of Danger Noodles, that there we go, yeah. So it always reminds me of just snakes. I mean, it can be hidden so easily inside of the application that you never know where it's going to be. So let's say I know Alice is an admin. Well, I just swap out Mallory to Alice, and I swap out user to admin. How is that going to be processed? How are we going to actually work with that information? Like, well, okay, we're not using that. We're not doing anything like that. Oh, and if I'm doing a white box assessment, so if I can actually see your source code, here are two functions that I'm actively looking for. So if I can see, if it's any time it's white box, I'm actively looking for those. If you are taking notes, this is a spot to take notes. So, but anyways, we'll move on because nobody wrote it down. Okay, so there's a project called WISO Serial. It's an excellent tool. It was initially created for Java deserialization attacks, where we could actually generate payloads, and we were specifically attacking the deserialization libraries. So that was really cool, but it was mainly for Java, so it kept going. And there we go. And so people have continued to port it to all the various languages. So now there's even one for .NET. So WISO Serial for .NET. I can create payloads, and I can specifically attack your .NET libraries. The easiest way to overcome deserialization issues is to update your libraries. So when your application uses an older version of .NET, this is the primary reason why, if you're using any serialization libraries, you should update those libraries. I know it's a pain, but it's well worth it to actually be able to update these libraries, because if I know there's an active vulnerability and I'm able to determine the .NET version, because damn .NET and IIS servers love telling you what .NET version they're using. If I'm able to figure that out and see that you're using serialization, if I'm able to pass serials to it, I'm going to try one of these. I'm going to generate a payload and pass it over to your server. All right. So that kind of brings us to another one. So we were just talking about deserialization. Really, that falls under known vulnerabilities. So the easiest way to overcome this is patch yourself. Does anybody know what this is? So just a hint, this is Java. And there's a payload right in the middle. Does anybody recognize this? Oh, it's a good old struts vulnerability. This is why at least 1 out of every 2 people in this room had their information stolen by Equifax, because we were able to do a unauthenticated command injection. This was something that had been patched 2 months before the compromise. It very easily could have been stopped, but you had to update the Apache struts libraries to be able to get around this, to be able to overcome this issue. But it wasn't done. Equifax just didn't do it. So that's why half of us had our information stolen. We've probably had it stolen more times than that, but there's not a whole lot we can do about that. And number 10, insufficient logging and monitoring. So there's a lot of text here. Essentially, if you don't know what's going on in your web application, if you don't know what the application is doing, or when I'm doing a pen test and you're not getting alerts, if you're not getting the information to detect, escalate, or just alert the right people of active attacks. Specifically, you can use SIMs to overcome this if your APIs aren't being monitored. If you're doing any of this and you're actively watching, eventually I will find a hole. I haven't had a single web application that we've pen tested that we haven't found one if given enough time. And if there's no active effort to actually help block these efforts, to block what I'm doing, or to actively or to react, such as an intrusion protection system or a web application firewall, that I can sit there and bang at it all day. I mean, I'm not really trying to go for denial of service. Yes, that could be a vulnerability that we find, but if you are not aware of what your application is doing and who's talking to it, then eventually somebody's going to find a way to break it. Eventually. Okay, so we have about 5 minutes. So notes time. So that felt like a lot, right? If you guys are going to write anything down, we're going to go. Oh no, I hit a button. Okay. So this is an excellent point to ask, do we want to recap on any one of these? So this is an excellent point to take any notes. Does anybody have any questions on any of this? Can we go in a deeper dive? Would you like to know more why I hate XXE and why it doesn't belong? Any questions?
So I have a comment.
Yeah.
In .NET specifically, the insecure deserialization critical hole is binary formatter. If you're using it, stop. It's insecure and cannot be made secure. And the .NET security people would really like to stop using it.
That's an important PSA. Any others? Any other questions, comments? So if you guys were interested in having me back again, I had the other half of my slides where I have the ability where we can talk about, okay, so I've just spent this time talking about the OWASP top 10, which is really nothing more than a popularity list, the most popular vulnerabilities that were found by Checkmarx and Veracode, and honestly, I think it's a poor list. If you guys want a better idea of what to do to protect your applications, the Common Weakness Enumeration Project, the CWE, which is not ran by OWASP, is an excellent place to start. Additionally, so it's just CWE or CWE 25, because it's a top 25 list. But the CWE 25 is an excellent tool to actually understand, because the things are moving around much better. There's actual users, the community support is there, so we can actually communicate and help move things up and down, add things, remove things when they're no longer really issues. CWE is way better than OWASP top 10. OWASP top 10 is like, OWASP top 10 is listed in PCI compliance, the PCI DSS compliance as a requirement that you must be OWASP top 10 compliant. What does that even mean? It's not a compliance framework. It's just the top 10. That's all it is. So I don't know why anybody's using it. I'm glad people are aware of it. I'm glad I'm here today talking about it. But use CWE 25 as well as ASVS, the Application Security Verification Assessment, or what's the S? I can't remember what the last S is. Anyways, ASVS. of OWASP that is a full-blown, like, multi-page checklist of the things you should be doing on your web application to actually secure it. It is a huge checklist that you can use. And when I do my pen tests, I have two different ways of doing the pen test. One is I'm looking for the weakest link. But there's also where sometimes you're asking me, hey, Kris, I need to be compliant. Can you go through this entire checklist and verify that none of these are here? And the ASVS is the framework that I use to point out, yes, you passed all these checks. So CWE 25 and ASVS version 4, which is the latest version. But if they release a new version, definitely check that one out. And if you guys will have me back again, I have a full-blown talk on hardening web applications as well as SQL injection. We could spend more than an hour talking about SQL injection if we really wanted to get to it. Any final questions? Nope. Well, thank you for having me. So, all right. Woo.